Well, how are you folks doing now? We are in week 5 of this stats course. I hope that you are enjoying your summer. Did you ever think you would be taking a stats course when the temperature is 80 and 90 degrees outside and we should be out doing the fun things of summer? Well, with stats, it is part of the fun things of summer. Now, like I said, this is week 5. Week 6, we're going to be introducing a concept. Week 7, another concept. Week 8, another concept. And voila! It's all over. It's all over. It'll be time to buy your fireworks. Today we're going to talk about 2 things, and hopefully the time will permit us. But we're going to be talking about probability. And probability, even though it may seem like an interesting term, an interesting word, probability is what is used in statistical operations. It is really an estimate. We are not positive in what we do in stats. We take our numbers and we're pretty sure what we're doing with our numbers is correct. But we don't know whether or not our findings as a result of using specific numbers is really what we want. So probability, even though we see that term time and time again, and this is statistics, probability is an estimate. That's what probability is an estimate. An estimate can be reduced to an educated guess. And that's what we are attempting to do. So often, we see and read a study, a research project. And following that research project, and I've seen this in text quite a few times, but following that research project, we have one that refutes all of the assignments and all of the statistics of the previous test. By when I say one person does research on it and has some findings. Another person does research on it and does not come up with the same findings. So this I want you to know about statistics, is that we deal a lot with probability, which is an estimate, which is an educated guess. Now going on from that, then, supposing that we had a coin toss. Now these are all of the possible outcomes of a coin toss. We could have all heads, 2 heads, a tail, head, tail, head, tail, head, head, and so forth on down the line. Well, if one were to ask, what is the probability of getting just one head, we would count these up. Here we have a head, just one head. Here we have a head, and here we have a head. Now, we have tossed the coin 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. We have found just one head, that's all I'm looking for, one head out of the 3 coin tosses, and it would be written 3 over 8. That's the way it would be written, 3 over 8. And then if we made a decimal point out of it, it would be 8 into 3, will go what? 0.375. Okay, then if we wanted a percent out of it, we would multiply this by 100, and we would have 37.5 times, this is a percent, we would come up with just one head. Again, probability, an estimation, an educated guess. So this is what we have here. If you toss a coin 8 times, these are the possible outcomes. And the possible outcomes, now it would be possible, I will say this, to have heads on all of these here, all of these, but we're looking for just one head. It would be possible to have all tails on this one of these. It would be possible to have a tail and two heads. It would be possible to have two heads and two tails on each of the 8 coin tosses. I realize that. But this basically is the possible outcomes that we could have, and I just wanted to show you the probability of this. Now, we have another design, and this design here is used very frequently in business statistics. And it's called the tree design. I'm going to go through the tree design with you, and then I'm going to look at a little bit of statistical significance and the meaning of this term, because I feel as though that you should definitely have the term in your mind of what statistical significance means. Okay, we have here what is called a tree design. In other words, we start here, we have a branch that goes up here, we have the probability stated on that branch, and then we have the outcome of a head. Now, if we had a coin and we flipped the coin, a possible outcome could be a head. If we took the same coin and flipped it again, and of course, statisticians always say that it has to be a fair coin. Well, that's kind of assumed, folks. It has to be a fair coin. But if we took on the other branch, flip the coin, the probability of getting a tail would be 0.5 on this area here of getting a tail. This would be the outcome. So it could go either way. Now, looking at this then a little bit further, when we go up here, we have the probability of getting a head, which is 0.5, and then getting a head and a head is 0.5 times 0.5. What I wanted to show you here is that when we go up this way, we multiply. We multiply this here. We multiply this here. We multiply this here. And when we multiply the 0.5 times the 0.5, we get a 0.25. Now, what is interesting with this tree is we multiply going this way, and we add going this way. Now, our total outcome should be 1. If we are correct in what we've done with our figuring, our total outcome is 1. Now, in business, these trees really become, in business statistics, these trees really become complicated as far as I'm concerned. At least there's a lot more to them, because they could take the outcome of a tail or a head, and then they could go ahead and take all of the tails, we'll say between the years 1990 and 2000, and we would have another one here, and then we could have another one here between 2000 and 2010. We could have another tail here, and the same thing with the head. We could look at the dates of the coins, and then we could look at the condition of the coin, good condition, poor condition, for the tail, good condition, poor condition. And what I want to show you here is that these trees, the tree design, can become very, very, I shouldn't really say complicated, but very, very precise. Now, having told you that now, I want to go on to statistical significance, or what is statistically significant. Now, if we have our normal curve, as we have drawn it so many times that a person should be able to draw it quite good after a while, and we have an alpha level here. I want to explain this alpha level to you. You can select any alpha level that you would like. Most of the time, the alpha level that is selected is 0.05. And then if we divide that by 2, we have 2.5. So on this tail here, we have 2.5, and on this tail here, we have 2.5. Now, mentioning this here, I want to say that an alpha level can be any level that you select as a researcher. Now, this here, of course, is a z-score curve, and we have our mean of 0. So what this is here is 1.96 negative. Again, this is alpha level 0.05, and this here is a positive 1.96. So, any number that is less than this here number is statistically significant. Any number that is more than 1.96 is statistically significant. So everything that is falls in this area here and this area here, we fail to reject the null. Only when it moves outside of here, this area here, does it become statistically significant. Now, having said that then, going on, and I will relate to this a little bit later on, not in this video, but possibly in another video, I just wanted to draw this for you and let you know that as a researcher, this is a z-score curve again with a mean of 0, and as a researcher, you can set any alpha level that you would wish to use. Now, I'm going to go to an extreme on this. I don't want to be misunderstood. I want to go to an extreme on this just to show you how this works. You could set an alpha level of 50. That means then that you would have 25 here and 25 here. So you'd have 25 on each side of it. And we're saying that this is a two-tailed test. So if we have our null hypothesis in this area here, remember this here is 25, and this here is 25. Hopefully you catch this, because I'm going to review it again with you. But if we set it here, then anything that falls outside of this level right here, will be statistically significant. Now then, in the case of possibly a pill or a new treatment, then you can see that this here is 25 and 25. That equals 50. The whole curve equals 100. So basically what this would be saying is that the pill works about half of the time. Now there's be some concerns in this area if it just worked half the time. I'm going to bring this to you again. I hope that all is going well. If not, you know where I am. Give me send me an email message letting me know what is happening if you're having problems. Well, this time is winding down quite quickly. We basically have 3 concepts that we're going to be looking at, and I will be bringing you another wonderful video for your summer's enjoyment. So until then, you have a good day, and we'll be seeing you.